Here we go. At last, it's time for our Expedition Aya closing ceremony. The Expedition Aya has been a 6-week initiative, a global open build challenge with the goal of both connecting researchers and pushing the boundaries of multilingual AI research. I think it's worth noting that many of the teams here today met for the first time just a little over 6 weeks ago and have been collaborating in brand new ways, having to establish not just what they would be working on, but how they would be working on it together, often across time zones, across the world, and across levels of experience and expertise in ML research. And I think that no matter what happens from the research today, this is already a huge victory. And we knew starting the expedition that 6 weeks was incredibly ambitious as a timeline for a research project. And our goal, and what I'm happy to hear from many of the teams already, is that this would be the seed to new research collaborations, and that 6 weeks would hopefully be enough time to get projects off the ground. And I've been very happy to hear that many teams continue to hope working together. And so the judges have been briefed that this is the case. We're not expecting to see complete projects by any means, and the judges will be here considering the ideas and the progress made so far. And so quick agenda, what you can expect today, a quick introduction. We're doing it now. It's going great. Then we'll have the 5-minute lightning talks from our 20 teams. Teams, you've been briefed. I'll be quite strict on the time today, just to help us move through as much as possible. There will unfortunately not be time for live questions, but please put questions in the chat as they come up, and the presenters will be able to address those once they finish their lightning talks. Then we'll have a 15-minute break for judges' deliberation. We'll keep this tab open. So just keep this tab open as you go to do whatever you'd like for 15 minutes. And you'll hear my voice again when that time is up and when the judges have come to their decision. Then we'll just reconvene very briefly for the judges to announce the top prizes, and we'll celebrate all the work that's happened over the past few months. I'm very, very pleased to introduce our judges today. Thank you so much for being with us. We are honored to have with us Sebastian, who's a research scientist at Cohere and working on making LLMs multilingual. Prior to this, he was at Google DeepMind and completed his PhD in NLP and deep learning at the Insight Research Center for Data Analytics. Welcome, Sebastian. So glad you're here. We also have with us Marzieh, who's a senior research scientist at Cohere for AI, interested in all aspects of natural language understanding, including multilingual learning, data conscious learning, robust and scalable models. Prior to this, Marzieh was the NLP and ML research lead at Zeta Alpha Vector and did her PhD at the Language Technology Lab in University of Amsterdam. Marzieh, so glad you're here, and thank you so much for agreeing to judge today. Yes, I'm seeing all the celebration now. Keep it going for our final judge, Alice. Alice is at Cohere working on ML safety and believes in all instances of ML use cases for good. Prior to being at Cohere, Alice was at Twitter working on trust and safety and was the chief data scientist at IGF Finances. Alice, thank you so much for being a judge with us here as well today. Okay, so what can we expect? We'll be awarding 5 prizes at the end of the session: gold, silver, bronze, most innovative, and most promising. With this, I think it's time to get to our main event. So teams, I will pass it off to you for your presentations, 5 minutes each. I don't know if I've said that enough. And yeah, I'd like to invite everyone to be active in the chat. Share your feedback with our teams, any questions you have, if you have ideas to support the next stages of their research. Really looking forward to this being a celebratory time for all of us. Okay, with that, we'll get to it. Our first presentation today is from the Multi-Agent Aya for Workforce team. Madi and Dristi, over to you.
Thanks so much, Madeline. Yes, first of all, I want to thank everybody from Aya team, Cohere team for creating this opportunity for us to connect with amazing researchers around the globe and experiment with a bunch of crazy ideas. And also like the crew team and extended team, crew team that they helped us with to get here in the past 6-7 weeks. So if please next, I will get started with the idea. So idea of the project, in my daily job, I work with large digital enterprises, and what I observe is that they're mostly distributed, and one of the main bottlenecks for them is communication. They are distributed across the globe. They interact, and most of them, they don't have English language as their first language, basically. And they have to use apps, machine translation apps, etc. And enterprise companies consider a lot of training, investing a lot of money on training these teams, or paying for machine translation systems, apps that are like inefficient. And there are a lot of problems with these systems, which are general systems, but they're not adapted to certain domains, for example. And so idea of this project was to like experiment with Aya, see if we can deploy Aya in larger scale, and enable organizations to use Aya as a backbone for translation. So a multilingual, multi-agent system that allows communication for the users. Next slide, please. So as you know, enterprise data has always been sensitive to companies. So this kind of data set is not existing out there. So what we thought was to come up with synthetic data and synthetic dialogue data, which are multilingual. So we tried to, in this course of this project, to create and generate this kind of data set. It's not available yet, but we plan to publish it and benchmark several models against this data set. So we try to model different sources of misinterpretations in this generated data and evaluate different models against it, including Aya, and understand like where Aya's position is, given the fine-tuning or RAG support. Several misinterpretations are multiple layers of communication in enterprise, lack of standardization, low resource languages, and generally lost in translation is one of major effects in this and these systems, basically, that we try to model in this kind of data set. Next part of the conversation is about like deploying Aya in the multi-agent system that Roshan will present. Thank you.
Yeah, for the next presentation is basically just the chat application that we have developed, and yeah, you can just go through the video presentation on that. Language continues to be a significant barrier for large enterprises, especially with teams that are spread across different geographies. For this project, I have developed a multilingual chat application to address these barriers along with other workplace inefficiencies. The application utilizes a LLM-powered multi-agent framework which is built upon LangGraph and is powered by various LLM options, including Aya. Multilingual translation is the key feature of the app, and its primary characteristic is that it's context-aware, which means that the translation of a message is done while using the previous messages as context. In this example, we can see three users having a conversation in English, French, and Spanish simultaneously. Another key feature is Aya, a multilingual workplace AI assistant to improve efficiency. One of the ways Aya does that is by answering user questions through a RAG-based system that is connected to the company's knowledge base. In this example, I have fed Aya Expeditions meeting slides from last week to the system, and I'm asking Aya the names of the judges for this event. If you're an expert on a particular topic, quite frequently people will reach out to you directly with their questions and doubts. Answering these same questions again and again can be very inefficient and time consuming. With the documentation on the go feature, you can now save your chat messages directly to the company knowledge base. So the next time somebody has a similar question, Aya can answer it for you instead. In this example, we can see how Aya is able to answer a question that it previously didn't know the answer to. Smart Summarize is a feature that allows you to quickly catch up on a chat thread by summarizing the messages. It also implements task identification, which specifically retrieves any action items that were mentioned in the chat. In this example between two users discussing the closing ceremony, Aya provides a summary of the discussion along with the action item assigned to one of the users. For the future, we do have certain ideas in mind. On the research side, we plan to fine-tune a small language model to act as the orchestration model for the system. This would allow it to be run locally and potentially improve the on latency. And to support this, we also plan to develop a dataset with orchestration-like instructions. On the product end, we plan to include new integrations covering various work-based tools, as well as continue working on improving the simplify feature that we have.
Excellent. Thank you so much to Madi, Roshan, and the whole multi-agent team. Congratulations. We won't have time for questions at this point, but please put them in the chat if so. All right, next up is...
Okay. I count with you, Madeline, with passing the slides. Okay. You can move forward already. In the multilingual crisis management, what we intended to do is to see how these LLMs can be implemented to enhance the response capabilities of the governmental institutions when responding to critical situations such as like terrorist attack or natural disasters. For doing this, we first try to look into what was the existing data, and we noticed that it's very centric to specific countries that they have developed these alert messages, but it's not available worldwide. So we augment that data with those examples for every country in the world, and also implementing different types of alert messages for natural disasters to wildlife. Then we use these alert messages generated with Cohere Plus, and we translated them to different languages using the Cohere and the two Aya models. And we use the main Cohere, the Plus, as the reference for the blue mention marks that we will show later. And to finish the project, we develop a platform in the long term so volunteers can finish validating the quality of this translation, so we don't have to fully rely on the blue scores. You can move forward. Slides. Yeah. So the initial result shows that for the human dataset, the blue scores was under 50%. But if we move one slide further, we can see that the synthetic dataset actually showed a much higher performance than the human dataset centric data. And it reached almost even 60% or 56% in the case of French language. If we move forward, we can see how this dependency, we notice that in the human dataset, there's a big fluctuation in the performance of the blue scores depending to the type of alert types. For example, severe unrest have a high performance in Spanish, but others have lower performance in other categories. And if we move forward, we can see that in the synthetic dataset, this situation is way more balanced, probably due to the fact that they have from the main data source, like the Cohere Plus. And if we move forward, we also wanted to see how this data is composed for. So we can move one slide more, and we can see the initial state of this human dataset, how it's being distributed in the two-dimensional space, and one more to see the synthetic generated data. And we see that the purpose of expanding this data into more knowledge, basically, it shows a good output. But if we move forward and we separate how this data looks into each individual category, we can notice different clusters. For example, in the wildlife, it makes sense that it's very centralized because of the characteristics of these alert messages. They are mainly related to animal specifications. And in the human type of alerts, they are very much related to all of the other topics. So to finish the project, you can move forward to the last, one more. We show a few screenshots of how this labeling tool would work. The idea is that the user logins and choose the language that they want to collaborate with. They see the instructions that they have to mark these translations and define if it's highly accurate or highly inaccurate. or middle brackets. And the idea for this is that in the future, this open source data set will provide like full high quality of, so people can use the highly accurate ones and fix the highly inaccurate eventually, or decide what to do then. You can just move to the last one, and it's, thank you.
Excellent. Thank you so much, Augustine, and congrats to you and to Rosina, and congrats on the progress here. Excellent.
She's there
With this, what's this?
She's here now, so you can see.
Oh, hello, Rosina. Congrats to you too. Okay,
Thank you.
with this, we'll move on to the evaluating reward models in multilingual settings team. Srishti, you're presenting today. Over to you.
Hi, everyone. So my name is Srishti, and I'm going to be presenting from the multilingual reward model team. So next slide. Let's talk about LLMs. How do we train LLMs? We take a lot of internet data, we take a model, throw that data on the model, and then ask the model to just learn the language. But this is problematic for the reason that the internet data consists of a lot of negative and toxic data, and we don't want our model to learn that because we want to make it safe for the public to consume. Here kicks in RLHF as one of the techniques to make these models safe for the humans to consume. When I talk about RLHF, I can't really skip reward models for the reasons that these reward models are the ones that we rely on. Like these are the oracle on which we rely on to get the signal of whether an answer to a response, is it safe or is it unsafe? So that's how important reward models are to the RLHF pipeline. Now, to date, at least according to my knowledge, there is no extensive work that benchmarks how these reward models perform for the purpose that they are meant for. Reward bench is one work, but it's only for the English language. Here we kick in. We take one step further and we thoroughly evaluate a lot of reward models for the multilingual setting for a suite of total 23 languages. Next slide. So what we do is that, next slide, Madam, please. Yeah, so what we do is that we take the original reward bench dataset that consists of triples. Now triples are like a prompt, a safe response or a preferred response, and a non-preferred response. This data set is totally in English, but we want to see the capabilities of reward models for non-English languages as well. So we take this data set, use the NLLB model, which is targeted to translation, and translate this data set into a suite of total 23 languages, and then evaluate 16 proprietary and open source reward models on these 23 data sets. And next slide shows the numbers that we have. So a lot of numbers, I'm not going to explain each one of them, but we can clearly see that some models are very bad at all of the languages. Some models are good at some languages while bad at the others. Some models are a mix of these two. But yeah, what the signal that we get from here is that we really need to pay attention to the capabilities of the reward models as far as all of the languages, including English, non-English, like all of the languages are concerned. Next slide. This is actually a pretty interesting slide because this shows that how does the accuracy score of these reward models change when we shift from English to some non-English language. So what we've done over here is that we've taken an average of those 23 languages. But what we can see is that even for our best performing model, there is a significant drop of around 7 to 8% from English to other non-English languages. And this drop is most significant for the reasoning category and the least significant for the safety category. So yeah, and next slide. So on the next slide, what we now wanted to focus on is that since we used a machine learning model itself to translate the data set from English to non-English languages, is it the translation quality that's really getting reflected in these numbers that we have for all the reward models? So it's kind of a confounded property and we wanted to check this. So we took a better translator. We took the Google Translate API, which is actually pretty nice. And then we translate the English data set into 3 different languages, Hindi, Indonesian, and traditional Chinese using the Google Translate API. And here are the numbers. So what we see is that there is actually some improvement from the NLLB translated dataset to the Google Translate translated dataset. And this number is the most significant for traditional Chinese across all categories, which is chat, safety, chat hard, and reasoning. And the reason for this is actually known. The reason is that the NLLB model isn't really good at translating to CJK, which is Chinese, Japanese, and Korean. And that is what we also find. So next slide. It shows our third finding, which is also an interesting experiment that we did. So let's say I'm a user and I have a question which says, what do you do? The response says, I'm a doctor, or I'm an engineer, I'm a teacher, or whatever profession. So these reward models should really score each of these pairs equally and shouldn't really show a bias towards any particular profession, but they actually do show a bias, which is very clearly apparent here. Red ones are low scores and blue ones are higher scores. So yeah, this is also one experiment that we did. Now, another very important direction of our work is that while we translated the data sets from English to some other language, did the gold preference labels change? Maybe due to cultural reasons or some other reasons. So what we did is that we set up human evals for 2 languages as of now, Indonesian and Spanish, and then we see how much are the reward bench labels in sync with the human labels, humans that speak Indonesian and Spanish. And we find out that the percentage is more for Spanish and less for Indonesian. And then we also evaluated a reward model, which is Llama 3.18 billion. Like, it's a generative model. We use it as LLM as a judge and see how well it is in sync with the human given label. Those numbers are also over here. And as expected, they're not so good. So next slide. This is our dataset number 2. This dataset looks like a source sentence in English, a preferred translation in some other language, and a non-preferred translation in that same language. So it is a mix of English plus some non-English language dataset. And then we evaluate our reward models on these dataset to get a sense of how well these models are able to evaluate, this translation kind of a thing. So the numbers are over here. These look decent, at least to me. So, and this is an ongoing experiment, by the way. It's not completed yet, and we are doing this for...
I personally think if someone asked to play a drill, should play a drill. The technique.
Sorry, Shrishti, you can continue.
Okay, sure. Yeah, and we are continuing this experiment for a whole lot of reward models. So next slide. Yeah, so to wrap things up, the final thoughts from my side are that we really need to pay a lot of attention to these reward models as far as the multilingual setting is concerned, so as to make sure that the models that we are aligning using these reward models are safe for the global population to consume, for everyone to consume, and not just for the English-speaking population. And so, yeah, that's it. And our data set and code, everything is open source, available online. Feel free to check it out. What's in progress is that we are really working hard on improving the quality of translations. We are also setting up human evals to check for preference inversion and preference preservation. And yeah, that's it. Our appendix is also attached. Feel free to check it. Thank you.
Congrats, Shrishti, and to your whole team. Thanks for the presentation.
Thank you.
Next, we have identifying mislabeled samples in the Aya dataset. Amar, am I handing it over to you?
Yeah, thank you, Madeline. So first, yeah, I'm glad to be presenting this on behalf of my team, Jeffrey, Chishum, Marek, Michelle, and Chayek. So our project mainly focuses on instruction tuning datasets, and specifically on the Aya dataset, which has more than 200,000 samples in 71 languages, and the rows are as shown to the right. So each row has an input and then a desired target, and it's assigned to a specific language. Next, please. So with a huge data set that covers more than 70 languages, we are expecting to have some mislabeled samples. So that's an example of a sample we found in the Hindi split, in which we have an input that is, imagine a futuristic society where robots and humans coexist, and then write a scene about that. But actually, the target is a Hindi translation of the English prompt instead of a scene that's actually being described. So why is this actually problematic? Next, please. So we know these data sets are actually used to fine-tune models. Next, please. So when we queried the Aya23 model, which is fine-tuned on the data set, with the exact inputs, we find that first it actually spits out the verbatim targets that we had, and then it's actually starting to generate a scene, but this time in Hindi, which I assume isn't what the user would have expected. Next, please. So this kind of phenomena is studied, and it's termed as language confusion. But that's maybe one more reason for this language confusion, which is issues actually within the fine-tuning data, more than how sampling is being done or other reasons. Next, please. So for us to discover these samples or potentially mislabeled samples, we first discarded duplicates within the dataset, and notably a language like Yoruba has more than 5,000 samples that are actually duplicated, representing more than 43% of the data, which is a chain. So that's the first step. Next, please. And then we also decided to discard trivially short inputs and targets. So ones having less than 4 tokens. And for counting the tokens, we used stanza. So to the left, you can see some examples in the English dataset, which at least to me, they look to be trivially noisy or unimportant. And then the table to the right shows actually the languages with the largest number of trivially short samples. So you can see Tamil with 132, and then we can contrast that with Igbo, for instance, with 81. But when we actually checked both languages, we found that they are not actually the same. Next, please. So for Tamil, you have lots of short prompts in the sense of asking to translate an English term or a word into Tamil, which are the ones shown to the left. But for Igbo, actually, one of the team members can speak the language, and she also confirmed, actually, for Igbo, it's not the same case. These are actually trivially samples that need to be discarded. So we can use human verification for that, but we also attempted to use large language model as a judge, and for that we used command arctos. So the histograms shown below show the ratings for the samples that we identified in both languages. And you can see for Tamil, for Tamil, this is not the right histogram. As you can see, it's the same one, actually. That's an issue. Anyway, for Tamil, if you trust me, their words were actually leaning toward higher scores, while for Igbo, as you can see, it's actually the other way around. It's assigning it low scores. So that's kind of promising in the sense that we can use that as maybe one more step for verification. Next, please. And the last step was for us to actually identify the language of both the inputs and targets. And based on that, we can generate multiple splits of the remaining data set. So the first part is what we call the misplaced split. So as shown below, these are samples that are assigned to English, but then if you check them, they are not really English. Both the inputs and targets are not English. So they need to be moved to another split of the data set. Next, please. And then for another kind of issue when it comes to labels is similar to the motivating example we had initially, in which we have an input and target in 2 different languages. And not only that, but actually with misalignment between the inputs and targets. So the instruction is not to translate the input into a target, and then we have that. So that's an issue we can detect based on that. And then the remaining parts goes into what we call cleaned Aya dataset. Next, please. So this method is promising when it comes to actually finding inputs and targets in 2 different languages that need to be discarded in the sense that they're not aligned. But we also notice that this method flags languages like Standard Malay, Standard Arabic, and Portuguese. And in verifying these, for instance, for the first one, the model was basically confusing between Standard Malay and Indonesian. So it's kind of more of an false negative from the language ID model and not really an issue with the dataset. And similarly for Standard Arabic, it was confusing between Standard Arabic and some dialects, specifically for really short targets or inputs. And for Portuguese, we also have had a sense that's the case. Next, please. So for Standard Arabic, for instance, we decided to look deeper into actually the inputs. So for these 2 histograms, we compute what's called the level of dialectness, which is a metric introduced to define how a sentence diverges from standard language, and 0 implies no divergence from standard language. And as you can see, the distribution of these scores for both the inputs and targets is actually mainly centric around a score of 0, which means they are indeed in Standard Arabic. So instead of using dialect identification, this can also show us if the sentences are mainly Standard Arabic. And as we can see, both inputs and targets are actually the same. Next, please. So to conclude, we managed to design an effective pipeline for flagging potentially mislabeled samples. We need human in the loop to verify these samples. And we also find that large language model as a judge or perplexity show promising results in helping present. Thank you.
Thank you very much. Congrats, Amar, to you and to your team. Next, we have the synthetic multilingual instruction generation team. Jessica, over to you.
Hi everyone. So here is a project synthetic multilingual instruction generation. So coming to the problem statement, like our primary motivation for this project was, to address the lack of high quality instruction data for low resource languages. And most instruction datasets are actually focused on more popular languages. And also for the case of like low resource languages, there are things like website licensing, which limits scraping as an option. For example, for Aya 101, we tried it with an Indic language, and after like going ahead with 250, after we checked like 250 different data sets, 250 different websites, we were only able to find 5 to 6 different websites which are like non-licensed, and we were able to scrape them, but it's very difficult. And as previous research has shown, we require such datasets, instruction datasets, to boost the performance of the model on downstream tasks in the respective languages. And therefore, to address this, like we wanted to like create a scalable methodology for generating non-licensed synthetic multilingual instruction dataset, which can help community and also the companies. And the approach we broadly use like 3 different approaches, which utilized various techniques, including context-based generation, distillation, and translation, amongst others. We'll be covering these approaches. It's the next slide, yeah. Sorry. We broadly use like 3 different approaches, which utilized various techniques, including context-based generation, distillation, and translation, amongst others. We'll be covering these approaches in detail in the next coming slides. But for our POC, we primarily went with Hindi, but our approaches scale irrespective. Scale very easily for other languages as well. We've primarily utilized Llama because of the non-licensed generations and also its state-of-the-art performance. And coming to the next slide. Coming to a first approach, which is the Orca approach, we leverage the Orca dataset, which is an extension of the FLAN dataset. But as part of the Orca, what do they do is they include like more descriptive prompts, such as think step by step, or think before you speak, or like give the explanation before you give the answer. This helps actually get the longer outputs. But the problem with this is that the responses are actually like generated from GPT-4, making it like a licensed dataset. We replaced it with we replaced it with Llama 3.1 70 billion model to generate the responses, thus making it like like a non-licensed dataset. So once we get this distilled dataset from Llama, we further translate. So we further filter out the data which is like which might not be very relevant for translation to downstream tasks. So from that we get like close to like 100,000 English only like dataset. The advantage of this is that we can use this to translate it into any language we want. And in our case, we translate it into Hindi, and we got the Hindi dataset. And yeah, I think the next slide, I think Roshan can take it.
For the second approach, we use the Hindi Wikipedia corpus to extract paragraphs that are then passed as context to Llama to generate question-answer pairs. With the initial generations, we observed that the answers tended to be shorter and not as descriptive. Therefore, to address this, we gave the generated questions again to Llama to generate longer, more descriptive responses. We further manipulate the generated context question answer pairs to come up with new types of instructions, and this basically helps us create a larger, more diverse instruction data set. Next slide. For our final approach, we utilize 2 versions of the FLAN dataset, the original version along with the chain of thought variation. These samples were then translated to Hindi using the Llama model. The key modifications that we performed included filtering the longer outputs and also resampling the dataset to maintain an even distribution amongst the different task types. Next slide. All right. So at the end of all of this, we have created around 250,000 instructions with 130,000 in Hindi and the remaining in English. And the table below gives a very high-level overview of the data sets that are being generated by each approach. Next slide.
So at the end of like the 6 weeks, we are able to like present a dataset that stands out as being one of the largest and most diverse like Hindi datasets. and all of our datasets are non-licensed and can be used for both like commercial and non-commercial purposes. And in terms of the limitations, we realized that certain subsets of our datasets might be helpful more for small language models rather than LLMs, because we rely on the LLM output generation itself. And to address this, we're planning a self-instructive. And additionally, limitations include the availability of like non-licensed corpora and existing LLMs translation capability to like very low resource languages, and also ultimately like we might need some GP credits for running Llama. So the next slide, regarding the future work, like we are currently like fine-tuning models on our data sets, and we're planning to benchmark it. This should be done like within 1 to 1.5 weeks. And we're also like expanding into other languages, for example, like Pashto language. We're thinking of also like introducing new question types for context tasks such as MCQs, fill in blanks, true or false, etc. We also plan to like make a Hugging Face submission on our Orca-based dataset to see its accuracy. We also like plan to discuss with like Indian startups who are working on like multilingual SLMs on utilizing our dataset. There are a few such startups, and so yeah, we have added our dataset samples, the prompts, and the data transformation which we did in the appendix for everyone's reference. So yeah, that's it with our presentation.
Congrats, Desik, Roshan, and to your team. Thank you so much for your presentation. Next up, DistAYA.
Hi everyone, I'm Ahmed and I'll be presenting today for DistAYA. And first of all, thank you to the Cohere API team for arranging this Aya expedition and all of our collaborators. So I'll talk first about the problem statement. So as we know that large language models have many deployment challenges and these are autoregressive models. So as the number of tokens are increasing, the memory requirements and the latest latency requirements are also increasing, which makes it difficult to deploy, especially on the edge devices. So the goal of this project is that we wanted to create multilingual language models that not only match the power of large multilingual models, but also are being more compact and can run on edge devices. So we wanted to retain the linguistic diversity of Aya 23.8b while significantly reducing the size for real-world applications. Next slide, please. So we considered 5 potential techniques to reduce the size of Aya models. So the first technique is pruning, which can be further divided into 3 parts: unstructured pruning, structured pruning, and semi-structured pruning. Then the second technique is knowledge distillation, in which we have a student and teacher model. Then there is quantization, which can be further divided into 2 parts. So quantization aware training and post-training quantization, then low-rank factorization and fine-tuning as well. Next slide, please. So the first technique that we used was SparseGPT. SparseGPT was introduced in this paper. Massive language models can be accurately pruned in one shot. And SparseGPT helps us enable 50% pruning of large language models without retaining by using a layer-wise approach. And the Aya model, we uniformly pruned Aya model in all linear layers, excluding the embedding and the head, as standard to 50% unstructured sparsity, as you can see in the second bar in the bar plot. So the first bar is the dense Aya 23B model. The second is the uniform sparsity model, which has 50% unstructured sparsity. Then we have 2:4 sparse model, which uses semi-structured pattern of n:(m) sparsity format. And there are 2 forms with stringent and partial sparsity, when one must choose a subset of layer to n:(m) sparsity. And you can read the paper for more details. And the last technique here is the joint sparsity and quantization, in which we combine the sparsification and quantization, which would allow combining computational speed up from sparsity with memory saving from quantization. And we can see that there is a perplexity, the perplexity scores is increasing as we move forward. Next slide, please. Then we have short GPT technique, which was introduced in layers in large language models are more redundant than you expect. In this technique, we explored the number of layers which are not important in the Aya model, and we found we calculated the number of layers which would have the smallest effect on KLD loss or DI block influence metric. And we found that layer 3, 6, and layer number 10 are the layers that have smallest effect on KLD when these are removed. And we can see in the metrics, in the evaluation metrics on the right side, that the MMLU for English language for the base Aya model value has a value of 0.45. Whereas with pruning, the value drops to 0.22. Due to compute constraints, we were only able to run the evaluation for English language. Next slide, please. Then the next technique is hidden state-based distillation, which is the distill kit that is basically that allows us to perform task-aware layer-wise distillation. And in this case, we used Aya 23.8b as a teacher model and 22.7b as the student model. And we can see that as the distillation steps are increasing, the value of MMLU is also decreasing. But in this case, the student model that we were using, which is 22.7b, is already stronger student model than the teacher model. So, and we were not able to run the evaluations on all of our ablations, but we plan to do the compute constraint, but we plan to continue further on this experiment. Next slide, please. And the last technique that we explored is fine tuning, in which we used 1.5B model, base model, and we constructed a data set that has 540,000 rows, and it consists of 5 different languages. It consists of Bangla, English, Urdu, Arabic, and French. And we fine-tune this model end-to-end for one epoch on 1.5B, and we can see the graph for loss values in the right side. We have not run the evaluations on it yet due to next slide, please. And this is a work in progress. We plan to continue our experiments, and these are some of the future works that we would like to explore for this trial. Next slide, please. Thank you very much. And our codes and data sets are all available on Hugging Face, and you can see them on this link of your code.
Congrats, Ahmed, and to the DistAYA team. Bravo. Next up, we have the Climate Resilient Communities Multilingual Climate Chatbot. Over to you. Louis, are you presenting today?
Yes, I'll
Yes.
We'll start.
Yeah, so hi everyone, my name is Helena. Our project is focused on building a multilingual climate chatbot. Our team consists of Louis, Mariam, Afnit, and also Karen. Next slide, please. So our project aims to make climate research and education accessible to all Torontonians, regardless of their cultural and linguistic backgrounds. Many Torontonians lack understanding of climate risks and actions they can take, leading to limited engagement, high climate anxiety, and inequality in decision-making power, particularly among young and marginalized communities. Existing climate information is disjointed, jargon-filled, and often exclude non-English speakers and marginalized communities. Next slide, please. So with our solution, we offer timely, accurate, and easy to understand information through Aya and Command R+ on local climate risk, adaptation strategies, and best practices for climate risk mitigations and recovery process. The chatbot helps individuals and communities better understand how to mitigate, prepare for, and respond to climate impacts. It empowers individuals and communities to engage more effectively with climate risk, fostering increased inclusivity, climate literacy, and community actions. I'll now pass to Mariam to talk about the architectures.
Hi everyone. Our RAG architecture is as follows. We start with curated climate documents on climate risks and adaptation, and convert each chunk of text into two embeddings. One is a dense embedding from Cohere multilingual embedding for the meaning, and another one is a sparse embedding from BM25 encoder for the keywords. We store our embeddings in a Pinecone database. When a query is made, we also convert it into two embeddings and perform a hybrid search based on semantic and keyword similarities. Retrieved documents then are reordered with a Cohere rank model. Next slide, please. And now let me walk you through our chatbot architecture. We first check if the question is related to climate change. If it is, we retrieve documents from our RAG system. If retrieved documents have relevant information, we generate an answer. If not, we perform a web search, and then we check for hallucinations. And finally, we confirm that the generated response is actually addressing the question. In summary, there are several checkpoints to ensure that the response is factual, accurate, and relevant. Now I pass it over to Avneet.
So for the evaluations, we mainly adopted three techniques: LLM as a judge, cosine similarity, and human evaluations. For LLM as a judge, we basically generated a data set using ChatGPT. And with that, we were able to achieve a high correlation of 89%. We also used cosine similarity for improved retrieval precision, and were able to achieve a mean similarity score of 93%. And we also did some human evaluations within the team, and they seem to ensure consistent app performance. Now I'd like to pass it on to Louis for the demo.
Perfect. So, madam, I believe next slide, please. And you started at 142, please. Yes.
Hi, everyone. Welcome to the Multilingual Climate Chatbot.
One moment.
We're excited to show you today how our chatbot works. Here, you can ask the question to please translate the same question in Spanish, French, and Mandarin. As you can see here, we have the 4 questions. So let's go ask our chatbot. For the purpose of time, we have asked the chatbot, ask the same question in Spanish, was able to pull it out, same question in French, was able to pull information out, and the same question in Mandarin. Now, how do we compare those answers? Let's use Cohere. So asking Cohere, we can ask it to please compare the translation and give it a score for the translation, and give a mean overall score from 0 to 100. So let's see how our chatbot did comparing the English to Spanish, French, and Mandarin. So Cohere gave a score of 90% for the Spanish, 95% for the French, and Mandarin 85. So we had an overall score of 90%. This to us is a very big success, as we wanted to give out the information from the Toronto communities to different types of languages without different types of language documentation. Thank you.
Next slide, please. And we'll pass it over to Karen.
Hi, everyone. Welcome to the Multilingual Climate Chatbot.
One moment.
We're
Sorry.
excited to show you today.
There we go.
So Karen.
Hi everyone. I will walk you through our MLCC project roadmap, focusing on making our app safer, faster, and more inclusive. By September, we will boost our RAG system and integrate wildcard for enhanced safety and ethical filtering. We will also refine our model and partner with Cohere. By November, we will launch MLCC Basic, gather feedback, and boost user engagement. By December, we will refine our approach, establish a content update pipeline, and analyze feedback. Then in the new year, January 2025, we will develop MLCC advanced features for climate adaptation and resilience planning, personalized risk communication, and spatial temporal data, making our app more precise and localized. These steps ensure MLCC becomes a safe, responsive, and global tool. Thank you.
For the next slide, if anyone has questions, wants to try the app, please try it there. And any questions, just let us know. Thank you.
Thank you, and congrats to your whole team. So great to hear from so many of you today. Next up, the Maya group.
Hi everyone. This is Nahid. Yeah, I'm going to present Maya Multimodal Aya. Me, Karthik, and Surya are co-leading the project. Next slide, please. Yeah, so what's the problem here? Like, if you look at existing vision language models, they are either like 1 or 2 languages. And there is a huge lack of open source quality, multilingual, multimodal data set, actually. And that leads to a lot of like models that are not really diverse and aware of like various different cultures. So what we propose with Maya is to build an open source multimodal, multilingual model using Aya that can process both text and images. To begin with, we support 8 languages. Next, please. So how do we do it? The architecture is based off of Lava 1.5. In the first version, we essentially replaced Vicuna with Aya, and we replaced the image encoder clip with a multilingual SIGLIP. So for this purpose, really, what we really had to create is this novel multilingual, multimodal dataset for pre-training the model. And for instruction tuning, we used, for now, Palo 150K dataset. From the research impact perspective, you can see that this is really a huge impact because this is really a first ever multimodal, multilingual pre-training dataset that did not exist before. So this bridges a gap in the vision language model in the multilingual space. Next slide, please. So the dataset team, once they created the pre-training dataset, this is, we train on the model based off of Aya 23, 8 billion model. And this slide basically shows like the lot of training we did, as you can capture. There are 8 languages. And next slide, please. And this one here, like we tested some sample images and their corresponding output on all those 8 languages. We can only fit like 4 of them in one slide. So you can look at it here. Next slide, and I'll pass it to Karthik.
Yeah, hi everyone. As you can see in the first workflow, we started with Lava pre-trained dataset, which contains 558K rows in English, each with a human value and GPT value. For human value, we identified 11 unique instructions and translated them into 7 languages using Google Translate. Then our team manually refined these translations with ChatGPT, Claude, and Gemini to ensure accuracy. Now, if you can see for GPT value, we selected 30 samples based on various metrics like text length, readability, and other metrics. We applied the same translation and review process to create a ground truth data set for evaluating different preamble prompts. So in the second workflow diagram, to use the Aya 35B model for translations, we developed 6 prompts and tested them. We choose the best one by comparing blue scores and n-gram coverage against our reference translated text dataset that we created earlier. Next slide, please. If you can see here, there are 2 graphs. The first graph is explaining how each preamble type is performing across different language. And if you see in the second chart, it's basically radar chart based on n-gram averages for all the languages by each preamble type. And we see that preamble 6 performed best across all languages. So we used it to create our multilingual dataset. Next slide, please. So by batching API calls to Aya 35B model, we quickly translated data and combined it with human values, resulting in a comprehensive data set of 4.7 million rows, including English. This is all. Next, Surya. Next slide.
Yep. So like only after we have done the whole complete translation and when we are doing the spot check-in on how good the translation is, we found out there are toxic data points in the data set, and it's kind of a shock because like it's a widely spread used data set in the computer vision community. So we thought of doing a toxicity analysis, both using the test information and also the image information. With the test information, like we use the toxic bird to label into like different kinds of toxicity labels, and we have tried with different threshold to get the most optimal number of toxic elements with less false positives, and we found around like 0.8 threshold works good, and we got around like 800 samples which are toxic. Next slide, please. Yep. And we also have the image information with us, which gives us a lot more information than the test. So we used LavaGuard, we passed a safety policy, and we got the results for the unsafe images, and we fine-grained those results using command R plus models, and we got around like 7.5K unsafe, toxic data points in the data set. Although this number looks very small, but when we are extending it into the more languages, it can multiply into a large number. Next slide, please. Yep. And apart from that, we have also done a translation, like quality assurance, in terms of how good the translations are, to filter the bad translation and to retranslate them. So the first thing we have done is the checking whether any tokens have been repeated, because it's a most common issue in some of the models where the same words have been repeated multiple times. So we just checked whether any tokens have been repeated which are not present in the English test. And in that, like, we found around 7% of the translations had repetitions occurring. And we also have we also checked using the back translation. So we back translated from the translated test to English, and we compared with the reference English test, and we calculated different metrics like CHRF score and blue score. Next slide. And like, this is the analysis we have done. Like, we have only plotted the CHRF score, and here you can see like French is performing good and Arabic is performing slightly worse than other languages. So this kind of in progress. We are ready to do more analysis to filter out the bad translation. Next slide, please.
Yeah, so these are our next steps. You can follow up them. We have our Maya model release coming up soon. Stay tuned to Aya and C4AI community. Next step, please. Next slide. Yeah, thanks to our team Maya, who it would be impossible without them. And next slide, please. Yeah, you can download our Maya pre-trained dataset. It is available now with toxicity free. So just go ahead. If you have any feedback or questions, please email us. Thank you for Cohere for AI and Expedition Aya team for giving us this opportunity. Yep.
And a huge congrats to you, Team Maya. Great to hear about your work, the next steps coming up.
Yeah.
All right, next up we have multilingual machine-generated text portion detection.
Hello, everyone. My name is Ashish Srivastava, and I'm here to present our solution for a significant challenge in the digital age, multilingual machine-generated text detection. The rise of large language models has revolutionized content creation, but also poses a significant challenge in distinguishing between human and AI-generated text, especially in the spread of misinformation, which spreads 6 times faster than generated by AI. This makes it crucial to distinguish between human and AI-generated text. Next slide, please. Most existing research focuses on binary classification, which is either human-written or LLM-generated. However, this approach overlooks cases where text is partially generated by LLMs. To address this gap, we took a deeper dive by implementing a token classification approach. Next slide, please. We developed a dataset of 330,000 annotated samples with plans to expand it to over 5 million. This dataset spans a range of text types: research paper abstracts, academic essays, online reviews, and news articles. Of these, 10% are fully human written, another 10% are entirely generated by LLMs, and then the remaining 80% represent partial cases. Next slide, please. Our dataset covers 23 languages, which are the same as those covered by Aya 23. These include right-to-left languages, low-to-mid-resource languages, and languages without words. For Chinese and Japanese, as there are no words, we evaluate them character-wise. Next slide, please. Different scenarios have unique requirements. In the realm of academia, the goal is to maintain a high detection rate while also avoiding false accusations. For social media, we focus on detecting as much as possible while minimizing misdetections. Each use case demands a tailored approach to meet these varying needs. Next slide, please. And thus, ensembles give us the flexibility to adjust classification criteria based on specific needs. For instance, we can prioritize recall by requiring all models to agree, or focus on precision by allowing just one model to predict a label. This flexibility helps us adjust our model's performance for specific use cases, ensuring reliability across different scenarios. Next slide, please. These are the metrics we've achieved across each language. For example, in the case of fake news detection, we prioritize recall to ensure we capture as much misinformation as possible. Next slide, please. Where existing proprietary systems falter on shorter text, our model consistently excels, delivering superior performance regardless of text length. Next slide, please. Our model currently supports 23 languages and will soon extend to over 100, while existing systems only cover a few high-resource languages. Unlike other models that are tailored to specific LLM texts, ours is a single model that works across all LLMs. We've also trained our model using a much broader range of publicly available data, and with less than 1% the amount of training data used by proprietary systems, we still achieve significantly better results. Next slide, please. We've also tested our model on unseen LLM outputs, including data from GPT-4 and Llama. Even though proprietary systems were trained on the same LLMs, they still delivered less accurate results compared to our model. Next slide, please. In partial LLM cases, the recall of our model was more or less the same, irrespective of the proportion of LLM human proportions. Next slide, please. We're extending our work to support even more languages and LLMs, both open source and proprietary, building a larger and diverse corpus. This expanded dataset will not only enhance detection, but can be applied to other linguistic tasks, such as identifying writing styles. We're also planning to tackle more complex scenarios, like handling cases where multiple LLMs are used within the same text. Additionally, we'll be applying this approach to social media content, including AI-generated posts, comments, and replies. Next slide, please. Finally, these are our team members without whom this project could not have been possible. Next slide, please. You can find our dataset on Hugging Face using the QR code below. We are currently pursuing many other multilingual focused papers in NLP, and if you have any other questions, you can contact us through the emails provided. Thank you, everyone.
Thank you, Ashay. Thanks for the great presentation and congrats to your whole team. Next up, we have Sanskriti Aya, Designing Linguistic Quality Index to Analyze Conversational Capabilities of LLMs.
Yeah, hi everyone. I guess the introduction is quite like bold here, but there's a significance behind this image. This is me being burdened by the linguistic concepts, which I love, because the point is that this project focused upon how to prioritize linguistics, like basically design with them the linguistic index, the quality index for conversational agents that we are kind of using all around now. The focus was that, can you go to the next slide, please? We can enjoy the image later on. I'll forward it in the group as well. But yeah, coming to the problem statement, it's basically like LLMs are being used as conversational agent, and there's a significant lack of a great evaluation framework that can like assess linguistic qualities and cultural qualities together. So our aim was that this is more like a theoretical work that we did, and our aim was that we could, through this 6 weeks of sprint, we could come up with an initial set of an initial design of a framework, which we, in terms of like what are the parameters that we need to use, and how to define a conversation basically that happens with the LLM. Now there are two parts to it. The one part is like what we focused upon in this set was synthetic data generation, where we actually generated synthetic conversations and we evaluated it using our framework. The second part, which we are going to continue next, is going to have like a real human talking to a machine and we kind of analyzing that communication with the framework, so that we can have a comparison as well later on how a synthetic conversation happens, and if a real life conversation is happening, how it will take place. So we have basically like that was my problem statement. And can you go to the next slide, please, Medla? Yeah, motivation was behind this was, as I said, like we want to facilitate dialogues, basically personal, educational, and professional context. You're talking about conversational agents being everywhere. So it's very important that in multilingual setting, we have a framework that can define the quality at each and every place, wherever they are being used. Now, in our project, we focused upon like 4 languages: English, Hindi, Gujarati, and Marathi. And as I said, like the main focus was designing the framework, where on the next slide, you're soon going to see the framework that we have defined. It's a very comprehensive one. We have already gone through like 35 to 40 papers. We checked out what are the linguistic capabilities people are checking out in different papers, how are they defining those linguistic qualities. So our idea was to compile it up and structure it in a way that we have a single go-to system. In linguistics, we have found out that there is no proper definition of conversations as well. And being in like right now in a era where we are kind of synergizing the conversational agents, it's important to come up with this single kind of a breakdown framework which can break down a conversation for everyone for later on to evaluate and do any kind of qualitative and quantifiable evaluation. So what are these parameters? We are talking about coherence, pragmatics defined, cultural pragmatics, and registers. So coherence is basically like syntactic conversation where we talk about the structure of the conversation, where we have three metrics: anaphora, cataphora, and deixis. So I'm going to explain it in the next slide. And semantic, so I'll can you go back? I'll just walk through quickly all the parameters and then yeah. So semantic coherence has basically a Grice's maxim, which is a linguistic framework, which we have used to define a semantic coherence, which talks about relevance, quality, quantity. And then we have the pragmatics, where presupposition is what is the shared knowledge that the conversational agents or any two people who are talking about have. Implicators are all related to indirect meanings, where we have like conventional implicators, which are usually indicated by conjunctions. And then we have conversational implicators, which are mostly about indirect references that are being made in a conversation in the right manner. Now, cultural pragmatics are very generalized here, which we are planning to break down, which are related to biases and cultural hallucination, where bias means like any kind of stereotype and cultural hallucination means that it doesn't have any knowledge related to that cultural concept. We have also designed registers, which talks about the tones of the conversation, where we have used Leach's definition, which is formal, frozen, casual, consultative, and intimate. But we are going to increase it further based on politeness maxim. So these are all linguistic frameworks that we have actually walked and read through, and we have designed this quality framework. So if we go to the next slide, I'll kind of explain some of it. So this is like a conversational breakdown where we have like anaphora, cataphora, deixis, and all these defined and scored. So you can read through the conversation. It is mostly about like a person, two bosses talking about a female co-worker not working very well. So you will be able to see, and this is generated by GPT. So there we were able to generate bias very easily as well. So they're talking about like some roles aren't good fit for female workers. So you can imagine that there is a bias here. So we have talked about like anaphora, how basically the pronouns and the noun structure are correct. Cataphora is a category which we have removed from our analysis later on, but it is non-existent here as well, so I won't go into it. Deixis is more about like indirect references or like hanging variables not being there. So basically there are no hanging words which are without any context. So there are a lot of times the words are being used which don't have any correlation with any of the other sentences, and they're just hanging in the sentence, so it's not there. Semantic coherence, I've talked about the maxims that are there, so it's a very quantifiable metric. Presupposition is shared knowledge, which is there because they have the context about the person whom they're talking about. Conventional implicators are proper use of conjunctions. Conversational implicator is that they have the exact meaning and they are implying the exact meaning of what they want to talk about that particular female employee. I've talked about biases and expected register. The tone is formal and consultative, as I've said. So expected was that, and even exhibited was that. So can we move ahead to the next slide? Yeah, so the themes of conversations that we simulated were simulating wedding conversation, festival and cultural rituals, food and family get-together simulations, basically. Next slide. Yeah, analysis report for ChatGPT. We had done on 23 conversations because these are very difficult parameters to rate, and we are humanly annotating every conversations that we have simulated. So if you look at the performance, I'll give you like the good ones, which are more juicy ones, which are basically the grammatical errors are quite high in the Marathi and the Gujarati languages. If you see, it's almost around 70%. It's greater than 70%, so it's very dangerously high. Semantic coherence is, semantic coherence is quite low. If you can see, it's below 30%. And I'm going to just quickly walk through. Overgeneration is something that we have observed a lot, and cultural hallucination was also more than 50%. And code mixing was also observed, like around 30% in Marathi and 64% in Gujarati, which is crazily high. So going to the next slide, I'll quickly just tell you the observation. Mostly Marathi, we saw overgenerations. We saw high level of inaccuracies of discourse markers and wrong use of honorifics. We also saw lack of cultural context. For Gujarati, there's similar like problems in terms of like lexicons being underdeveloped, a lot of foreign words coming up in between, and there's a lot of disagreement between the semantic and the syntactic coherence that was developed. Next slide, just 2 slides left right quickly. So for Hindi, it was noticeably higher, it was good, but there is a lot of old words being used which are not used anymore in the conversation. So it's a very important observation from us. English, very high quality, I would say it's almost 90% plus in terms of accuracy. Finally, just like to wrap it up, what are our next steps? We want to release like right now it was just on 23 conversation, 23 into 4. Right now we are going to generate 150 conversation each for 4 languages. We are also going to simulate the same experiment with human machine interaction, correlate this interaction with trust as well in terms of preference, so that we can do some preference tuning as well and create some like a language model to evaluate this, like using this framework of ours. Maybe work with Cohere to expand it to further languages to see what kind of outlook we have for a multilingual setup. So this is the scan me for like our data set. The final version of this data set would be available by the end of this week or most probably like Tuesday next week. So yeah, thank you. Sorry I took time. Yeah.
Thank you, Ganeet, and congrats to your team. Next, we've got Doclingual. Marzieh, are you presenting?
Bella is.
Hi,
Bella.
I am presenting. So both me and Srinakar will be presenting this presentation, but I'll start. So this is just so you get to know our team. Can you please go to the next line? Okay. So our core idea was to generate essentially a talk to your PDF application. But instead of doing what everybody else doing, we really wanted to focus on law documents. So that was our key application. And the reason we wanted to do is just to have a greater impact. And it's not only something that we think ourselves, but the Sustainable Development Goals thinks too. It has a lot of focus on peace, justice, and strong institutions. And we believe our work can act as a tool, as an enabling technology, and to reduce language barriers. Next slide, please. So our idea was quite simple, to find a data set which was law-focused, build a retriever, and to keep our LLM frozen just to act as an interface between our retriever model and our final user. Next, please. So to have this data set would work, we would need a data set that has both context and questions and answers, and we could not find such document or such data set. So we end up creating our own data set, and we chose to go with the Multi-Urlex dataset, which has over 65,000 laws, and they have the same laws in different languages. So that was one of the reasons we wanted to do it. We wanted to use this dataset, and we ended up choosing 5 languages, which were the languages that the people in our team could speak, because we first evaluated ourselves the questions that we were answering. And I ended up going with Command R because its results were better than all the other models, and they were very similar to Command R+. We couldn't ourselves distinguish between the two of them. We generated 2,500 questions for all the documents, and we can expand this in the future. And then to annotate the answers, that was quite tricky because then we would need to have a law background. So we also use LLM as a judge. We use 4 different LLM models, and then we actually were interested in if they were agreeing or disagreeing with each other, and we really saw them as annotators. Next slide, please. So on the dataset evaluation, we first asked the LLM models to rate 0 to 5, and you can see that the median ratings are quite good. But when you look at the Cohen kappa, which is our metric to see how much they agree, they don't agree that much. And you see that this pattern of real-linked and embedded agreeing with each other is quite strong compared to the others. One quick notice is that both Cohen and Twice kappa, they're not 0 to 1. They can be negative if they disagree a lot. And usually from 2 is already a fair good agreement because it also takes in consideration just your random expected agreement. So, next slide, please. We wanted to see if the entropy was distributed across the data set or just in questions that were poor. And it's actually kind of random. So it does not have a pattern, which means that the median rating is not a good correlation to that, which means we cannot see how much they are disagreeing with each other. So next slide, please. So to see if it was because of the 0 to 5 was not giving enough room for the models to evaluate, we redid this analysis, but going 0 to 10. Next slide, please. And we can see that although we have promising results when we look at the medium ratings, the models start rating more 6s and 7s than before. But actually, when you look at the entropy, you can see that they still disagreeing on which data set is, which question is good and which question is bad. So next slide. And we can see that it also changes as expected, because it has a greater number of categories. Our agreement goes down, but it still holds true that we rank and embedded rate the questions very similarly. But now we switch from the mapping that we had before. So right now, command R is closer to those than it was before. Next slide, please. So here's what we do if we can do all combinations possible. And we can see from the 0 to 5, we have a good agreement between re-rank and embedded, but we also have a good agreement between command R plus re-rank and embedded. And on below, you can see that they just disagree everywhere if you ask them to rate 0 to 10. And it's most just re-rank and embedded that agree with each other. Next slide, please. So we know that the models are thinking our answers are good, but they disagree on which ones are not. And we know that so far it's not related to 0 to 5. We plan to evaluate this data set further to see if it's language-based or document-based, but we're not there yet. And I'm just going to pass to Srinik, who's going to spend like the next step of our pipeline, which is the retriever model.
Yeah, so hi everyone. Sorry for not turning up the video on. I'm not in a good position, but still let me just try to keep my presentation as possible, as good as I can. So yeah, sort of the way how we build a retriever is we had a list of documents. So we are using the haystack pipeline. So it is something but a list of documents. And then I convert those documents to embeddings using embed multilingual V2 model of Cohere. And then I'm using another embedding of embed multilingual V2 to convert the query to embeddings. And then I'm using a cosine similarity between these both models using an in-memory retriever, which will perform a cosine similarity search, and then it will be passing that model to the LLM. So next slide, please. Yes, so over here, after the we get the list of documents which are very closest, we'll be using a prompt engineering kind of a thing, and we'll be generating using command R model. The reason we are going for command R, it produces better results. That's the reason for choosing command R. So yeah, that's how we generate the response. Yes, the next slide. So the overall workflow of how this pipeline works is available here. So you could see over here, it starts with text embedder, then a retriever and a prompt builder, and then LLM. Yeah, the next slide. Yeah, so this is the model evaluation pipeline. So the next slide would summarize all these together. Yeah, I've used the retriever model evaluation over here with different metrics like faithfulness, and aspect critic, and answer relevancy. So the faithfulness and answer critic didn't prove great evaluation metrics because they can't handle multilingual data. With the help of answer relevancy, I was able to understand that our retriever model is almost able to get to the right answers, and the few which are in the lower case are especially on the languages which are not very much familiar, especially on the European and other languages. Yes. So the next slide.
Okay, so just to wrap it up, our plan is to extend our data set further to the 23 languages that we have remaining and further validate it in more complex metrics. And especially also see if it's documents or IDs or the metrics. And then we also want to benchmark our approach against others, and we want to improve our retriever on unseen data. After we have this pipeline, we want to use low resources languages to also test this on low resources languages and generate the data set for low resources languages. And then we plan to restructure our code as a pipeline so people can use this out of the box. We also want to publish our data set when we have the complete version and write a paper. So thank you, everybody. That's all. Bye-bye.
Thank you and congrats to the Doclingual team. Next, we have Mechanistically, never can say this one, understanding Aya for safety steering. Marzieh, over to you.
Hi, hello everyone. My name is Ruder, and I'm very glad to present our project, Mechanistically Understanding Aya for Safety Steering. Next slide, please. Yeah, so as we know, and currently the large language models such as ChatGPT, Llama 3, Llama 2, they need extensive computing resources to pre-train and fine-tune to ensure the safe responses. But we actually don't know how LLMs refuse those harmful queries and how we could steer the LLM safety mechanism internally across the different languages. So based on these motivations, and we like to ask the 3 research questions. So the first is which residual stream layer of Aya 23 is responsible for the safety mechanism? And the second is, can we steer Aya 23 models activations for refusal across the different languages? And the third is, what kind of geometric properties does the multilingual harmful content have in the activation space? Next, please. Yeah, so here is the basic framework how we steer Aya 23. So here we use the paired bilingual prompts as an example to demonstrate this. So first, we will feed the harmful prompts in English and French into the Aya 23, and then we could extract the corresponding activation representations from each residual stream layer. And then here we mainly focus on the final token representation. So we could make the difference between the both languages at the final token representation, and then we got this difference representation. And then we could feed the new prompt, for example, in English, and then we could add this different representation to all tokens at the specific residual stream layer to change the activation space from the English to the French. Next slide, please. Yeah, so based on our this build framework, and we first conduct the experiments on the paired monolingual prompts. So for the harmful prompts, they are from the Aya red teaming datasets, and for the harmless prompts, and we actually use the general question answering dataset. And based on this figure, and we can find the Aya 23 actually is robust regarding the multilingual harmful prompts before the intervention. However, the refusal and safety score dramatically drops when we erase the refusal direction from the harmful activation representation. And the second experiment we conduct is we try to investigate whether we could steer the Aya 23 by using the language difference direction vector to transfer the input prompt from one language activation space to another one. So here we use the Aya red teaming dataset to test and use the cosine similarity to compare the semantic content before and after the intervention. So we can find based on this experiment and the Indo-European language family, especially for the Italic and Germanic subgrouping, actually achieved a higher similarity compared to the other subgrouping language family. And next slide, please. Yeah, and the final experiment we conduct is we try to explore the geometric structure of the different harmful topics in the projected 3D activation space under the multilingual setting. And here we visualize the English activation space, and we can find, so we here show the 4 harmful topics from Aya red teaming datasets in English, and we can find the hate speech, bullying, and discrimination are close to each other compared to the profanity topic. And based on this, we can find, because there were some overlaps between these previous 3 topics when we investigate the datasets, and it also means that it will be much harder to steer those similar topics in the activation space compared to the more distinguished harmful contents. Next slide, please. Yeah, and for our future work, and we plan to apply our methodology to more LLMs, such as Aya 23 certified bidding model and Llama 2, Llama 2, and Llama 3. And we also try to analyze the different components inside of LLM, such as the attention paths and LMP layers, and we try to build the full circuit and understand each LLM. And finally, we are currently drafting a workshop paper by summarizing all findings. So if you have further questions, and feel free to contact us. Thank you very much.
Thank you, and congrats to your team. Next up, Samskrutha LLM. Vivek, are you presenting?
Yeah, hi everyone, this is Samskrutha LLM team, and our goal was to improve Sanskrit generation in open source models. Next slide, please. So the problem that we faced while generating Sanskrit responses were we were often getting incomplete responses and amalgamation with the languages which follow the same language script Devanagari, which is like Marathi and Hindi. This is the result because the result is achieved because these LLMs are not being pre-trained on Sanskrit specifically, and they might have been like less than 1% of the whole dataset it has been trained on. We also noticed that popular LLM tokenizers are predominantly trained on web data and are inefficient at representing the Sanskrit language. Next slide, please. So we started off with choosing the right LLM for the experiment. So we selected Aya, Llama, and Gemma models for evaluating it on language detection, cosine similarity, BLUE score, and RU score. So for language detection part, we use Meta's fast text model for language classification. And based on the results, we selected Llama 3.18b and Gemma 2.9b for fine tuning. Next slide, please. So before moving on to fine tuning, we thought of using these prompt strategies to get the best out of these models. Hence, we implemented zero shot, 5 shot, and self-reflection on these models. However, we could not get a good improvement on these methods. So we moved on to fine tuning. Next slide, please. Yes. So we decided to fine tune these SLMs on translation and question answering tasks. We had a good quality of dataset for translation. Hence, it was easy for us to fine tune SLMs on Sanskrit data. However, that was not the case for question and answering. Hence, we had to generate synthetic data for it. For synthetic data, we used the corpus that we had collected, which was just Sanskrit text, and we fed it to a teacher LLM that was Llama 70b, and we generated some 11,000 question answer after thorough filtering and data cleaning. Next slide, please. Yeah, and these were the results. So I'm happy that we got good improvement over fine tuning for translation task over BLUE score, cosine similarity, and RU score, and we got a quite satisfactory result on question answering task that we had conducted. Next slide, please. Yes, talking about the tokenizer approach. So I just mentioned before how inefficient the tokenizers are for Sanskrit generation, and here we thought of a good approach to improve that. So there is always a trade-off between the vocabulary size and the token length, where both the thing has to be balanced properly. So we thought of dividing the Sanskrit text into nouns, verbs, and the other morphemes. In this case, the nouns have infinite numbers in the language space. So we thought of going forward with VP tokenization for it, so that it will tokenize nouns sub-optimally. For verbs and other morphemes that we have, they are pretty exhaustive in the language space. So we did word tokenization for that. And here in the image, you can see how the graph of graphings versus the token count is there. So in this case, the Indic languages like Hindi, which follow the same script as the Sanskrit, have much more amount of token count for graphing count. So next slide, please. Yes, so that was our work for 6 weeks. We would, in future, we would like to start crowdsourcing for good quality of data sets. Since Sanskrit is a low resource language, we could do only this much in 6 weeks. So using this good quality of data set, we would further continuously pre-train these SLMs and fine tune these SLMs on specific domains like textbooks where students would, it would be easy for students to learn from that. We'd also like to develop better evaluation benchmarks so that we can evaluate these models better, and also enhance the NLP tools so that we can support our tokenization scheme. Next slide, please. So that's it from our side. You can check out our recipes, datasets, and models on Hugging Face and GitHub repository. Also, you can reach out to us on Twitter And thank you so much, Cohere AI team, for giving us the opportunity to showcase our work.
Thank you, Vivek, and congrats to you and your team. Next, we have enhancing Sinhala NLP. Shamath Ramith, over to you.
Yeah, thank you, Madeline. So hello to everyone from around the world. Our goal is enhancing Sinhala NLP. So our team consists of all these 7 members who we all coordinated via Discord to tackle a significant challenge in Sinhala NLP. So with a population of 22 million and a digital literacy rate of 64%, with approximately around 72% speaking Sinhala as their primary language, Sri Lanka is the pearl of the Indian Ocean. So this just shows you the importance of enhancing the NLP capabilities for the Sinhala language. So next slide, please. Right. So given the limited infrastructure around Sinhala, we decided to address the problem from 3 different angles, working entirely from scratch. So the scarcity of instruction fine-tuning data, absence of robust evaluation benchmarks for MMLU, and local context were some of our main challenges. So currently only a few open source LLMs support Sinhala, including Aya 101 and Llama 3.1. Next slide, please. All right. So to address the limited instruction fine-tuning data, we translated the FLAN dataset. So after a thorough literature review, we focused on translating the most valuable subsets. So the dataset was so large. So we selected equal portions from each subset, skipping the tasks that required extensive manual intervention. So, but despite all these challenges, we were successfully able to achieve 10 million Sinhala entries, which is a great achievement, I believe. So the QR code available in the slide will take you to a detailed analysis of the dataset. Next slide, please, Madeline. All right. Okay. So we used Google Translator via Deep Translator and Google Cloud SDK for the translation process. We also developed scripts to manage the text length limits, ensuring accurate translation. So after completing the translation, we validated the results to ensure the continuity. So you can access the scripts as well by going into our QR there. So I won't go too detailed into the diagram available in the slide. Yes, next slide, please. Right. So we explored several open LLMs that had the exposure to Sinhala during the pre-training process. So after evaluating MT0, Gemma, Gemma 2, and Llama 3.1, we chose Gemma 2 9B for the fine-tuning. So based on the guidance we received from Marzieh, we fine-tuned a 1 million subset of the translated plan dataset. Next slide, please. Yes. So to create an evaluation benchmark, we translated the MMLU questions and made a data set of Sri Lankan exams on the following domain criteria you can see in the pie chart there. So as you can see, general knowledge, which is the leading percentage. So the number of subjects we covered were 14 as of right now. And as you can see, we selected MCQ type questions with focusing into MCQs without diagrams and questions that do not depend on each other. So this was done for evaluating our model's performance. So you can see the question and answer format there as well. Yes, next slide, please. Right. So these are the scores for Llama 3.1 and Aya 101 for the 57 subjects that are there. So as you can see, the overall score of Aya 101 is quite higher than Llama 3.1. So unfortunately, due to a technical difficulty, we couldn't evaluate our Sinhala Gemma model because the evaluation harness does not support Keras models. However, we plan to resolve this soon within the coming weeks, hopefully next week, and provide a comprehensive evaluation for our model. Yes, next slide, please. Right. So this is our project timeline throughout this past 6 weeks. So our participation in Expedition Aya was just the beginning. So 6 weeks is only the first iteration of our project, and we will refine our models, enhance benchmarks, and continue to advance Sinhala NLP. Yes, next slide, please. All right. So to conclude, our project lays the groundwork for enhancing Sinhala NLP. So we plan to release our data sets, models, and benchmarks publicly by November of this year. And additionally, we aim to publish a research paper to detail our findings. And we hope that the head start we got during these past 6 weeks will lead us to some more effective contributions in the future. Yeah, let's go to the last slide. Yes, so thank you so much for your time, and a huge shout out to the Cohere AI team for helping us out within these past 6 weeks. And we look forward to contributing further to the field of Sinhala NLP. Thank you so much.
Thank you, and congrats to your whole team. Next, we have the language effect. Christopher, are you presenting today?
Yeah, I will present. So yeah, I'm Christopher, and I'm happy to present the language effect team project and results. And I want to show you how important it is which prompt language you use when you're acting with a language model, especially regarding political opinions and knowledge. Next slide, please. I want to start with a quote to give you a picture. What is the project about? And here it is: language is the key to the world. Next slide, please. You can think of different doors, and if you want to open the door, you need a key to enter probably a different world. And next slide, please. And here we think of languages as the keys to unlock these doors to enter new worlds. And here we are especially focused on the political world, so opinions and knowledge, which are highly relevant if you want to get an understanding of what kind of world is embedded in the language model. Next slide, please. This comes from a lot of existing new work here showing the language sensitivity of these multilingual models, also for jailbreaking, as we have already seen in another talk. And here, the interesting part is that especially political bias tests are often focused on English and not really having this multilingual perspective. And if it's really the case that we're getting a different opinion, a different knowledge from the model just based on using a different interaction language for prompting, then it might give us a different political word by maybe assuming we will get the same. And that's why we use here Aya as an example and different pipelines to show you how we can quantize and discover these different worlds in the model. Next slide, please. So the question is it actually the language as a key to enter these political worlds? Next slide, please. And here we set up 2 pipelines. First, we are not just interested in the model behavior, also looked at the data more in detail to get an understanding how the language is distributed, especially regarding samples in the data which are linked to a certain language. So we labeled these different samples with statement labels, themes from political statement tests. So getting understanding how these topics and themes are distributed across the different languages. And not just that, we also try to get an understanding how the pre-stance is already in the data set. So we can maybe get an understanding of the link between the data and the actual behavior in the end of the model and comparing them. So on the other side, we have this behavioral view. We started to use existing and new political statement tests with hundreds of different statements, using it to translate the statements in the different languages, also adding a bit of variation and rephrasing for more robustness, and then getting the stances from Aya in these different languages and comparing it with an interlanguage agreement just based on the different responses from the model just by using a different prompt language. Next slide, please. What we can see for the data is that we have a highly different distribution for these political relevant topics based on the language. So especially English is very different from others. So just looking at one language might give you not the best picture of what is actually in the data set. And especially not just looking at the topics, we also looked at the stances. And what we can see is that especially for the stance here, immigrants from outside Europe should be required to accept our culture and values, it's highly negative having a disagreement regarding the stance on the English side, but not showing, and also on the French side, but not showing it, for example, with the statements in the data for the German language. So it's highly different just based on the language. Next slide, please. And we also try to get an understanding by applying and using the model behavior with getting the stances from the model regarding these political statements, applying 3 different political tests. And for the first ones, they are really common ones, political compass test and UNI test, we try to get an understanding of what is actually the stance of the model regarding these different topics. And what we're learning here is also that the alignment between the actual human survey responses with these tests and the model responses are different or not aligned for all languages similarly. So there are some which are really close to the model responses and others really, really far away. So the alignment here is a question to the actual responses. And there's also a really nice test, which is called the borderline dataset test, to get an understanding of territory knowledge aspects in such a model. So a question here is, for example, is Minera Reef a territory of Fiji or Tonga? So you get an understanding of what is embedded just based on the language. So here again, we use just different prompt languages, keeping the model the same and just getting an understanding if there's a difference. And what we can see is along all of these different political bias tests that the languages makes a difference. And here we used again the interlanguage agreement, showing a moderate agreement across all these languages, showing us that they act differently. Next slide, please. So to sum up, we can see for these political tests and showing you a pipeline to quantize this for language models to help you to get an understanding. And we can see this on the behavioral side and also for the data representation. And what we are currently into is trying to combine these two, tracing these stances, pre-stances from the data to the model behavior. Many thanks.
Thank you, Christopher, and congrats to your whole team. Next up is the SpeechAya team.
So, hi everyone. So, with the SpeechAya project, our goal was to create a multilingual LLM that can hear and speak. So, next slide, please. And we may wonder why we need to adapt LLM to speech modality. There are many reasons, but one important reason is that more than 90% of human languages are primarily oral, meaning that these languages are not written, actually. And these languages are often called low-resource languages, but the fact is that these languages are only resource in text. So they are not really low resource in speech, for example. And this is why many languages are underrepresented in technology, which is mainly focused in text. As the majority of human languages are not written, this suggests that if we really want to democratize the LLMs to everyone, we need to consider speech modality. So how can we achieve this? Next slide, please. How can we achieve this? So we want an LLM that can hear and speak in a unified fashion. One way to achieve this is to represent the speech as a text-like data, so we can train any LLM on that. For that, we used the speech tokenizer approach, which converts the speech modality to discrete tokens. And these discrete tokens can encode the content, the phonemes, the speaker identity, the rhythm, and many other things. And this model is totally unsupervised and is trained end-to-end to quantize the continuous speech. And our speech tokenizer is trained on English, common voice only, but in the future we want to train it on more data and languages. Next slide, please. And since now, thanks to the speech tokenizer, we can represent speech as a text-like data, we can just train any LLM using the next token prediction task. We can combine speech and data in many ways. So we used the speech-only data, so the LLM learned to understand and to generate from raw speech. We also used text-only data to ensure that the LLM retains its previous text knowledge acquired during the pre-training. And we can also interleave the text and speech data to form a bimodal instruction dataset. So to have this data, we used the common voice and Libre speech. And we only work on English and French. So next slide, please. Right now, we are training the small Qwen2 model on French and English only, but in the future, we would like to consider other languages, but for now, only for English and French. And the model is still in training right now, and it continues to improve in ISR, but it needs more training time and more data. Next slide, please. We have many open questions, and I think one interesting question is, can speech-only data improve low-resource language modeling for languages that don't have enough text data? And I think this is a very, very interesting question to explore. And there are also many open questions about the cross-modal transfer. For example, will the model be able to perform speech-to-speech translation or summarization without being trained on such data? And for the next steps, we project to train the model longer on more data and more languages. And we also want to improve the speech tokenizer to make it really multilingual. As for now, it's only trained on English. Thank you. So next slide. And you have the dataset. You can download the dataset and the models. And thank you very much. That's all for me.
Congrats, and thank you so much, Yaya, to you and to your team. Next up, we have SafeAya. Shant.
Hi there. I'm Simon, and we are the team forming the project SafeAya and present our project to making the Aya model safer. Next slide, please. So yeah, the main focus of our project is studying the jailbreak in the multilingual context, and the first half of our presentation will focusing on investigating the vulnerability of models, including Aya and also Llama under the popular kind of jailbreak attack methods. And our finding is the Aya model is still highly vulnerable to jailbreak. Next slide, please. So in corresponding to that, we also proposed that a way to train a safer Aya model to defend this attacks and achieving a more robust Aya model. Next slide, please. So here are the three objectives, or you could also say it's the research question that we set up at the beginning. So we wanted to study the vulnerability of open source models like Aya, especially under the multilingual kind of jailbreaking scenario. And the second point is one of our hypotheses is multilingual jailbreak would be more vulnerable if the model is having a better like multilingual capability. And thirdly, is related to, we also wanted to improve the safety and robustness of the model using the synthetic data that we will talk about it later. Bear with these 3 points. We'll come back to it later at the end of the presentation. Next slide, please. So yeah, here summarizes our contribution. So first of all, we explored how adversarial kind of vulnerable in multilingual models are, and as a contribution, we also released the dataset publicly for the multilingual ADV bench that we translated using Google Translate, and also the generated data that helps to improve the robustness. And thirdly, we train Aya with DPO for more robustness against attack. Next slide, please. So yeah, let's talk about the kind of our objective for the definition of this jailbreaking is we search for adversarial prompt or suffix that could elicit the harmful behavior from models, and we also wanted to investigate in the multilingual scenario. So next slide, please. So we put our effort firstly into translating the ADV bench that originally kind of constructed 520 harmful behavior in English and then translate them into 23 language, same set as the Aya model. And we tested on the models, not the proprietary models, on Llama 3 and also the Aya models. So next slide, please. So yeah, the first kind of jailbreak techniques or the experiments that we try is the GCG attack, which used the gradient information about the model and to use it as an optimization to generate the ADV prompt. And by talking about this, I will pass to Nish to talk about more details.
Oh, Madeline, is it possible to inaudible? Sorry.
Yes.
Yep. Next slide, please. So yeah, next slide. I think this is for like the ADV prompter. Yep. We first evaluated Llama 3.1 and Aya 8B on the multilingual ADV bench. That is like 23 languages across the entire 520 behaviors. So the bright red bar in the left is Llama 3.1 and the right is Aya 23. So the bright red bar is for English. You can see like Llama 3.1 is more likely to refuse harmful instructions, but the safety training does not generalize across all languages. You can see like high attack success rate, even like for baseline without any like GCG attack for like Turkish, Japanese, and Korean. Next slide, please. Yeah. So this is so first we start with the single harmful behavior. The bright red line is like for the English language, and for other colors are for the other language. We didn't want to show the entire 23 languages to clutter the plot, but you could see like we mainly first did not do for the entire 520 behaviors. So what we did was we picked only like 39 behaviors that are like more likely to be refused, that were refused by Llama 3.1 across all 23 languages. So we'll have like a good test of baseline that how GCG encourages to attack. So we could see like for English, we did run for 250 steps and we did try 30 different behaviors. Llama 3.1 is cannot be jailbroken in English. The loss never goes down by a lot. It increases maybe after like few around 4,000 steps. It may be like across like hundreds of different runs. Maybe the attack success rate is like 1% or less than that. But it corroborates with the story that Meta specifically adversarially safety trained Llama 3.1. And that could be seen that, but the Meta claims Llama 3.1 is multilingual. It does not the adversarial safety training for English does not translate to other languages. We could see like the loss for other languages specifically reduces really low, and it did increase the attack success rate. And similarly for Aya, we could see like specifically for specific languages that is not present in Llama 3.1, but Aya, the robustness is higher. Next, please. Next slide, please. So yep. Next is multiple harmful behaviors. So this is for 25 behaviors for English attack success rate, and there's also extra information for like 5 behaviors for multilingual. We could see as in the previous slide, Llama 3.1 the attack success rate is only 0 to 4%. This is for 1,000 steps, so it's very long. But the extra information is for multilingual for 5 behaviors. Llama 3.1 8B is like 70%. So that's a very high attack success rate, and it proves that adversarial safety training for English is not sufficient for a single language. We have to perform it for multilingually as well. Next slide, please.
So yeah, due to the time, I'm not going to explain about the ADV prompter, but this is the kind of the figures to illustrate how it works. Next slide, please. So basically, our results shows that the Aya model are still very vulnerable, having 73% of the jailbroken rate compared to 24% on the Llama 3 model. Next slide, please. And we also see that this could be transferred to other model, including the Command R and also the Command R plus, and leading to around 60% of the jailbroken rate in the top 1 and 96% in the top 10, which is worrying. So next slide, please. And yeah, so basically the way that we try to defend this is, next slide, please, via the DPO. So we use the Aya model that got jailbroken and also including the OpenAI, the ChatGPT, to as the chosen prompt. So next slide, please. And next slide, please. It's the same one. So yeah, basically we see on the fourth bar on the right-hand side, we see a much lower 95% more safety compared to the original Aya model. And on the left bottom corner, we also prove that our SafeAya not kind of having the false refusal rate and maintaining a even slightly higher uppercut eval to that doesn't lose its general capability. Next slide, please. So yeah, the multilingual, we are still working on that. So next slide, please. So yeah, basically to wrap up, we managed to study the vulnerability of the multilingual model. We didn't kind of finish the hypothesis define, and lastly, we haven't done the defenses for multilingual data, but we proved the alignment in monolingual data to improve the robustness. Next slide, please. Next slide. Yeah, it's just some future plan. We are continuing doing that and drafting a workshop paper. Next slide, please. So yeah, thank you. Here is our kind of data set, model, and code that is all available in Hugging Face and GitHub. And special thanks to Jenny and Marzieh for helping out this. Sorry for the overtime. Yep, thank you.
Congrats both. Thanks for your work. Next up, global exams. Harsha, are you presenting?
Yes. So thanks everyone for all the cool talks so far. I think with this global exams presentation, I want to talk about how fun it is to work with Aya and Cohere API in general. So this is the team, and this project is in collaboration with EPFL. So next slide, please. So we've talked about LLM eval quite a bit today, and I think it's something all of us really care about in the call and otherwise. It's academic, whether Twitter or otherwise. It's really, really important for us to look into that. And in particular, one form of eval that people are really interested in is exams. So why do we like exams and why are we interested in it? Beyond it being some form of mark of intelligence or some preference for that, they're standardized, they're consistent, and it shows and demonstrates that there are capabilities. If you solve a math question, you obviously know the steps to solve the equation. Beyond that, they're pretty multitask. Like, you need knowledge from math to solve physics questions and vice versa. And there's a diversity of topics. It can be a language exam, a civics exam, a driving license exam. So yeah, context and languages are also something you can scale across. So next slide, please. But we know LLM eval is hard. This example on the right is a classic example of, how many hours are in the word mirror? Like, doesn't really show up in our eval data set, so to speak. This is something we find in the wild. So to motivate that, next slide, please. I would say that multilingual eval is even harder, right? And this is something a lot of the world cares about. When they say an LLM, they say, is it multilingual? Is it multimodal? So next slide. So what I would say is that there's a need for native multilingual evals. So current eval data sets are mostly US and Western centric, as has been highlighted by a lot of folks so far. And the translation is not often reviewed that much because lack of resources, lack of access to speakers, similar topics. And also technical words are hard to translate. Error, mistake, and faults translate the same word in German. And there's also a distinction between accuracy and precision. Telugu is very weak. So next slide. this is another example where varg means a square, but it also has like 10 different meanings if you just use Google Translate. So next slide. So what do we need? We need a multilingual exam data set, and that's something we need to build. So moving on to the next slide. So the fix is what we're doing with the Expedition Aya as part of the global exams team. So the next slide. So initially, we started by collecting a lot of these exams. We built a JSON schema and with the collaborators, and we did pipelining using Command R+, GPT-4o, and our own OCR pipeline. We also got a ton of community contributions, and we have our own automated dataset checking, which is then reviewed and approved. So the next phase is LLM evaluation, analysis, and then writing the paper. So the next slide. So this is an idea of the schema that we're following. We want metadata so you can identify where the exam is coming from, questions coming from, what's the category. It's more for the practitioner to actually see where it's coming from. Also provenance, so you want traceability, and you also want features. And of course, you do want the question, options, and answer related to it. So next slide. So for that, also to make our lives a bit easier, we built our own dataset validation script, which does automatic schema validation, ensures that options are non-empty, and also does deduplication. So everybody who submits a dataset and processes it goes through this validation. Next slide, please. So these are the languages we've collected on the word cloud, and the right word cloud is some of the exams that are included. So there's a diverse set of coverage is what you can see. Next slide. So over 30,000 questions, multiple choice questions, non-translated, lot of effort put by everyone in collecting professional and academic questions and license tests, and almost 20 plus languages. So, and huge participation, if you can see from the split in the pie graph, huge participation in the community, really invaluable. So next slide. So yeah, multilingual eval stocks are rising because of the work we're doing for multilingual global exams. So the next slide. But there were challenges, just to wrap up quickly. PDF processing is hard, parsing is hard, and we use multimodal language models to directly extract it. But there was hallucination in non-Latin script, maybe an interesting project for the next expedition. And existing OCR, which are not LLM based, don't scale well, make a lot of mistakes. So in fact, it was easier to just do it manually. Semantic validation is still manual, and that could also be an interesting task for future things. And finding exams for certain languages are really hard. And that's something also community has come together to build up. So the next slide. So I'd like to say that we are still processing more exams till 31st of August. So happy to get more contributions. And yep, the next slide. Yep, got more exams to process. I'll leave you there. Thanks a lot for hearing my presentation.
Harsha, thank you so much, and congrats to the whole team. Next up, we've got StAyaL.
All right, so our team is called StAyaL, and our goal is to translate your personal style in multiple different languages. So how do we go about defining style? Next slide, please. So after multiple thought experiments, we define style as your personality conveyed through language, oftentimes in multiple different scenarios. And our goal was to take down the language barrier so you could be your true self across different scenarios, languages, cultures, etc. So why not just use a traditional translator for this? Next slide, please. So lots of times these translators will take away your emphasis, they'll take away kind of your adjectives, your own personal way of speaking. They can even make you sound insulting. One example, I was trying to tell my significant other that her dress was stunning. The translator said shocking or glaring. Clearly not what I was trying to say. So how do we address this scientifically? Next slide, please. So two women much smarter than me who really drove this process are going to go in depth. But from a high level standpoint, we wanted to take a small amount of text. We didn't want our speakers to have to write a novel to train a model. We didn't want you to have to self-stereotype in a prompt. We just wanted to take a small amount of text, combine it with the power of Cohere's tools, generate a style profile. And from there, I'm going to pass it along to Katrina. Next slide, please.
Thanks, Kyle. So data scientists and machine learning engineers spend on average 60% of their time cleaning and pre-processing data. This project was no exception. Next, please. We went through a rigorous and iterative process to prepare our data. We started off by collecting data from Aya in 6 different languages. We then extracted speaker quotes within the Aya dataset. We collected 100 lines of translated speaker data per language and combined the Aya data with our speaker data. Next, please. This resulted in 15 unique data sets of approximately 50,000 rows each. We have data in English, German, French, Spanish, Tamil, and Cantonese. Next, please. The embeddings are where the magic really started to happen for us. We were able to capture that intangible aspect of style and make it tangible and make it real. We settled on Cohere's Embed v3 model, which is language agnostic. We inputted our sentence chunks into the context window, and our model output a list of floats. Next, please. Once the embeddings were generated, we created topic clusters so that we could find true style without the noise of semantics. We used agglomerative clustering, which is unbridled, such that the number of clusters was not predetermined. I will pass it to Krishma for our data modeling. Next, please.
Beginning with the data augmentation, we computed the cosine similarity between the speaker's text embeddings and Aya's and kept those with the highest scores. In total, we were able to boost our data set from 100 records per speaker to over 10,000 in total. Next, please. Here's an example of the augmented results. Katrina, could you share your thoughts?
We were blown away by our results. The speakers thought the augmented data sets were actually their own. It picked up on their dialect, their slang, core values, and even figures of speech. Next, please.
We in fact computed the average cosine similarity among the speaker embeddings per cluster. And while this was lower than expected, during human evaluation, our 5 multilingual subject matter experts thought the noise was in fact very good in capturing text in varied contexts, which would improve the predictive capacity of our final model. Next, please. And so now I'll go into how we trained a contrastive learning model to detect style using our augmented data. We pass our data in as pairs, indicating same or different speaker and content for all languages. We then leveraged a Siamese network of 2 identical sister networks with dynamic weight sharing to map the data pairs while employing contrastive loss. Next, please. And here are our results. If you look to the diagram to the right, we see how in the latent space, our model is able to successfully separate similar and dissimilar pairs. So whether 2 texts belong to the same speaker. The trained model results are also compelling, with a test loss as low as 0.16. For next steps, there are so many avenues we'd like to explore. We're interested in using the learned model representation and generating stylistically consistent speaker text. Next, please.
So in conclusion, we took the science and math and really extracted the poetry and personality from our speakers. And communication is really what connects us all, obviously, and your personal style truly matters. So this is just the beginning of our project. We have quite a few use cases and quite a few different stretch goals that we'll be working on. On the next slide, you'll see our personal information. Please don't hesitate to reach out. Thank you all so very much for your time.
Thank you, and congrats to the whole StAyaL team. Next up, we've got perplexity versus model performance evaluation.
Yeah. Hi, everyone. Welcome to our presentation on perplexity versus model performance evaluation. And we're very excited to share our findings from the expedition. Also, thanks to everyone listed on this slide, as well as the Cohere AI team for organizing the expedition. Next slide, please. So our project investigates whether a model's perplexity on a question accurately predicts its likelihood of giving a correct answer to that question. Though there is existing research on the topic, the findings are very contradictory. This is also very underexplored in the multilingual setting. Next slide, please. We evaluated the Aya 23 models on the Hellerswag dataset, focusing on both English and the Okapi translations to assess performance across multiple languages. We chose this dataset due to its wide language coverage, making it ideal for cross-lingual evaluation. Next slide, please. We used 2 versions of the accuracy metric to quantify model performance, accuracy and accuracy norm, with the latter being normalized by the number of bytes. Though there is no clear consensus on which is a better metric, for our current analysis, we are primarily focused on the accuracy metric. Next slide, please. For perplexity, again, we look at word perplexity, which normalizes the likelihood by the number of words, and byte perplexity, which does so by the number of bytes. Due to the skewed nature of the word perplexity that you can see, we also construct log word perplexity and remove outliers. Next slide, please. While all the perplexity metrics showed high overlap in detecting outliers within a language, we see that there is less than 2% overlap when comparing outliers across different languages. This suggests that translated samples do not necessarily bring over their high perplexities to the new language. Next slide, please. Yeah, these are all the statistical tests that we run. We won't bore you with the details and move right into the insights. Next slide, please. Our dataset covers 30 languages, and only 14 of these are represented in the Aya model's data. We observed significant variation in the bytes to word ratio, forming two clear groups, one with a high ratio, which is mostly Indian languages, plus Russian, Armenian, and Ukrainian, and another with low ratio, mainly European languages, with exceptions like Vietnamese and Indonesian. Now over to Roshan to cover the other insights.
Could we go to the next slide? Yeah. So the first key observation that we made was the significance of languages that were present in the training data set versus languages that were not. For languages that were part of the Aya model training, we observed that lower perplexity indeed resulted in higher performance. This can be seen in the below graphs, where the red plots corresponding to the inaccurate samples tend to be higher or further ahead than the green plots corresponding to the accurate samples. Next slide. For languages that were not part of the training dataset, we observed a very interesting dual behavior of sorts. We saw that European languages like Swedish and Danish, there existed a negative relationship very similar to the trained languages. However, for more Asian and Indian languages, the relationship was actually positive, where lower perplexity was associated with lower performance. Next slide. So in order to quantify these observations, we computed correlation values between perplexity and the accuracy metrics. Consistent with the previous observation, we do see a strongly negative correlation between perplexity and accuracy for trained languages. A key exception here being the Hindi language, which shows a positive relation with the accuracy metric while having a negative relation with the accuracy norm metric. An open question for us to investigate further is whether this behavior is due to the high byte per word ratio of the Hindi language. Next slide. For untrained languages, we again observe the dual behavior, with European languages typically showing negative correlation and Indian languages showing positive correlation. Next slide. And to further validate these observations, we ran statistical tests to confirm the significance of these trends. As mentioned earlier, we used the independent t-test and its non-parametric counterpart, the Man-Whitney-U test. The results of these tests paint a very similar picture to what we have previously seen, with most of the trends showing up here as well. There's also an area where we are actively looking for feedback to improve on. Next slide. So in conclusion, is there a relationship between perplexity and model performance? Yes, our data suggests so. Does lower perplexity lead to higher model performance? Well, that depends. And it depends primarily on the language, where the model was trained on it or not, and other inherent characteristics of the language itself. Next slide. In terms of the future work, our primary goal right now is to scale up. This would mean running our analysis on combinations of more models and datasets to confirm if our observations hold true. We also want to investigate other areas like the relationship between word and byte perplexity, the effect of benchmark sources, and the significance of outliers in our dataset, and ultimately be able to publish these results. So yeah, that's it from us.
Congrats, and thanks so much to you and to your whole team. All right, with this, thank you, teams, for your incredible presentations. Wow, what a flood of information. Judges, it is time for you to head out and go to your breakout room link. Your 15 minutes starts now. So judges are going to go to their breakout room for 15 minutes. As they head out and deliberate, I'm going to invite Alejandro to tell us a little bit about the next initiative that we'll be having Cohere for AI and let you know how to get involved.
Yeah, thank you. So amazing presentations today. Really enjoyed watching them all. So congratulations to all the teams. Okay, but sadly, this is going to be over soon after we know the winners. So what's next? we're gonna do some research office hours. So starting on September 11, we're gonna have 1 hour every 2 weeks, where you can come to us with all your research questions around machine learning topics or large language models and all the Cohere 4AI open models, open data sets, and all the artifacts that we publish. Next slide, please. So what can you expect from these office hours? I hope we will have a lot of interesting discussions with some Cohere 4AI staff and with other community members. You can expect, hopefully, some answers to your research questions, but again, the worst that can happen is that we're going to have an interesting discussion. You can expect me, and you can expect some Cohere 4AI research scientists. Every 2 weeks, we will have something new, somebody new joining me. So yeah, it's going to be a lot of variety in backgrounds and interests. And yeah, Marcia might be there, Shivalika might be there, so some of the faces you already know will be there. And we are going to build this with you. We're going to be learning as we go. So if you have any ideas or things you would like to see or feedback once it happens, please reach out to me. We will be happy to incorporate all of your suggestions. And lastly, if there are some specific questions or topics you want to discuss during those office hours, also please reach out beforehand so we can try to prepare a little bit. But otherwise, you show up, and I'm pretty sure we will have a super nice time.
Nice, Alejandro. Thank you so much for telling us more about this and for taking the lead here today. I hope to see many of you at our first one on September 11th. For those of you working to continue the projects you're working on, or maybe another idea came from the work you've done, feel free to come by and check in. I think another nice thing about the office hours, or another way to use them, is for a bit of accountability. I know we felt that in the last 6 weeks with projects, that just knowing you had to be somewhere every week to give an update. You're welcome to just come by and tell us what you've been working on and get feedback on it, or just share your progress. Okay, so for now, I'm going to move to our hold screen to give us a bit of a break. The judges have up to 12 minutes left. Who knows? Maybe they're working more quickly than that. So please just keep this tab open, and I'll pop back on when I hear from the judges that they're ready to present. Okay, we'll see you all in 12 minutes or less. All right. Thank you so much to our judges for what I'm sure was a very challenging decision. I'm going to switch our slide presentation to announce our top prizes. All right, so first up to present our first prize today of most promising work. Marzieh, did you want to say a word about who's winning this prize and what brought you to this decision?
Yeah, hi everyone. That was a long but very exciting session that we just had. And I think in general, we can all agree, just looking at every presentation, so many great works, such a difficult task for us. But at the end of the day, we had to pick a few projects for the prizes. And the first one that I want to give this prize for most promising is, do we have a drum roll or anything? We don't. The most promising project in our eyes was the Maya project. So the Multimodal Aya project. I think it's very, very timely. Now we have a multilingual model that is state of the art, and there are multimodal models coming out every day, but almost none of them cover many languages, and it's a very timely, very important project, and there is a strong need for setting a high standard, as Aya is building on the top of leaderboards for multilingual evaluations to add multimodal capability to that as well. We've seen what this team has achieved in 6 weeks, and we are very sure that it will be it is the most promising. So we are very excited to see what they will continue to achieve and what they'll do next. Congratulations.
Congratulations to Team Maya. Okay, next up, we've got the most innovative work. Marzieh, I think you're speaking about this one as well.
Yeah, so this one was also very tricky. Our pick in the end for most innovative project has been the language effect project. So it's like the type of questions that they had was very interesting to us, and just looking at and they did a lot to study that. So building this really nice multilingual data set, and then looking at this like behavioral interlanguage agreement, and having nice analysis on toxicity as well in this like political domain. And the findings were also really interesting. So we were very happy and very excited about the innovation behind framing this question in a way that was very fresh to us. And I think the outcome of that project will be very useful for a lot of people. Congratulations.
Congratulations to the language effect team. Nice. Okay, thanks, Marzieh. I think now we're passing over to Sebastian to announce the bronze place team.
Cool, yeah. I just have to say quickly, I thought it was really amazing seeing all these great presentations and all the work that you've done over the last 6 weeks. It was really hard for us to choose like five projects. So just for the ones that we haven't chosen, that doesn't mean that you didn't do amazing work. It was just really tough competition this time. And so for the bronze prize, we chose the Sanskriti Aya, Designing Linguistic Quality Index to Analyze Conversational Capabilities of LLMs project. And what we really liked about this project is that this was kind of one of few and like a generally rare project that really bridges kind of NLP and linguistics work. We really liked how much thought they put into this linguistically motivated evaluation framework that they developed. We thought the analysis that they did in English and a lot of different Indian languages was really extensive and very nuanced. And in general, we are really, just kind of really excited to see this kind of interdisciplinary work, and really just want to encourage more work that really does this very in-depth analysis and really kind of thinking about how language is actually reflected. So great work, and hope to see more of that, and hope you delve even deeper into your results.
Bravo, congrats to the Sanskriti team. Okay, next up, our silver prize, Sebastian, who will we be hearing from now?
For the silver prize, we chose the Evaluating Reward Models in Multilingual Settings project. For this one, we thought the project or the topic that they tackled, reward modeling, like multilingually, is something that is really impactful and important to have, but quite understudied so far. So we think that the data set that they created through translating is going to be quite impactful and can be useful to others as well. And beyond that, we thought that the evaluation and analysis that they did really already provide a lot of immediate value and insights. We like that they studied a lot of different models and analyzed them, and that they also kind of very clearly presented key takeaways and observations that I think were already quite interesting to us, including performance drop in English and the impact of using different word choices across different languages. And finally, that they also kind of went beyond and created another language mixed reward modeling data set. So again, really great evaluation and great job on this project.
Nice, congrats to the rewards model team. Okay, and finally, this brings us to our last presentation for today. For the gold prize, Sebastian, who should we look to?
So for the gold prize, I'm really excited to announce that the winner is the MLCC project, the Multilingual Climate Chatbot. And I think for this project, we thought that it was very complete, very thorough treatment of a very impactful, timely topic. And we thought, the project really, I was personally very impressed of what they managed to accomplish in this timeline, and that they managed to design both quite complex, like RAG and chatbot architectures that weren't just straightforward chat, but actually took into consideration multiple different options, and only triggering if a question is actually related to climate change or climate research. That they had a very extensive evaluation, not just using automatic metrics, but looking at human evaluation as well, and that they had also a demo to share of how this can actually be used by users, as well as kind of nice, clearly communicated timeline towards launching, releasing this model, and having even further impact. So overall, very impressive work in this time frame, and we're really excited to see the launch of this model and just kind of further impact down the line.
Magnificent. Congrats to the MLCC team. And just a huge thank you to all of our judges, Sebastian, Marzieh, Alice, who had to sign off a little early. Thank you so much for staying with us and giving feedback on these incredible projects. We are really, really grateful for your time today. And huge congrats and thank you to all our teams. Thanks for sticking with us today on this long call, and thanks for sticking with us for the last few months. It's been remarkable to watch your progress, and I think it far exceeded the expectations of everyone here at Cohere for AI, how much engagement and the level of engagement we saw across teams and the diversity of work being done. I know that we are leaving feeling very inspired by you and your work, and I hope that that's been the same for you too. And please stay in touch. We want to keep helping out however we can as your projects progress, and let us know if there's anything else that we can be doing to lend a hand. So with that, we hope to see you at office hours September 11th, but at any of the other activities in the Cohere for AI community. I'll be in touch on Discord today and tomorrow with our winning teams to coordinate that, and also to just to make sure that we're staying in touch going forward. All right, let's call it a day. Congrats once again to all of our teams, to the winning teams, but to everyone for pushing the boundaries of multilingual AI. Thanks so much, and we'll see you around. Bye for now.